The sudden arrival of a cosmic tourist from the depths of interstellar space has transformed our solar system into a stage for one of the most spectacular astronomical events of the decade. This mysterious wanderer, officially designated 3I/Atlas, has startled astronomers with a dazzling show of erupting jets, shimmering dust, and an unusual brightness that defies expectations for a typical comet. As it races toward the sun on a steep hyperbolic trajectory, scientists around the world are watching with electrifying anticipation, unsure of what secrets it may reveal or what questions it may raise. For major space telescopes positioned across different regions of the planet have confirmed that 3I/Atlas does not behave like the garden-variety comets we occasionally see drifting through the skies. Instead, it seems to pulse with its own enigmatic energy, releasing colossal streams of vaporized ice and microscopic dust particles that fan out behind it like a cosmic beacon. These jets, illuminated by sunlight as the object barrels inward, appear almost as if the comet itself were communicating through bursts of celestial fire. The excitement has reached such a height that renowned theoretical physicist Michio Kaku has taken public interest in the object, addressing major news outlets and sharing his perspective with millions. According to Kaku, the sheer speed and trajectory of 3I/Atlas make it one of the most puzzling interstellar objects ever recorded. He emphasized that its hyperbolic path indicates it did not originate from within our own solar system, but instead traveled across the vast emptiness between stars, possibly for millions or even billions of years, before crossing paths with our sun. In a recent statement, Kaku explained that the coming days could be crucial as the comet approaches perihelion, the closest point in its orbit to the sun, offering scientists a rare opportunity to study how such an exotic object reacts to intense solar radiation. By observing the changes in speed, direction, and outgassing activity during its flyby, astronomers might uncover new insights into its composition, structure, and origins. 3I/Atlas has already shown behavior that challenges typical cometary models. Its jet activity, unusually powerful for its distance, suggests that volatile materials embedded deep within the body are being exposed and ignited by the increasing warmth of the sun. The result is a dramatic plume shooting outward like a geyser in space, stretching for thousands of miles and glowing in the reflected sunlight. Such intense activity raises intriguing possibilities. Either the comet is extraordinarily rich in volatile ices, or it possesses internal mechanisms not yet understood. The mystery deepens when considering the speed at which 3I/Atlas is traveling. Its high velocity relative to the solar system suggests origins in a far more distant region than the Oort cloud, a massive spherical shell of icy bodies surrounding the sun. Unlike typical comets that spend much of their time in predictable orbits, this object appears to be simply passing through, following a one-time trajectory that will eventually send it back into interstellar space, unless something unexpected occurs during its solar encounter. The release of recent imagery has only intensified the global frenzy. A breathtaking photograph captured on August 2nd by the 2-meter twin telescope at Spain's Tide Observatory shows 3I/Atlas in the midst of an enormous flare-up. The comet's core, heated by the sun's rays, shines brightly at the center of the image, while streams of dust and gas erupt outward in spectacular fashion. Astronomers analyzing the data describe the event as one of the brightest and most energetic outbursts ever recorded from an interstellar comet. The jet appears almost like a spear of cosmic energy, directed straight toward the sun, as if the object were responding to its gravitational pull or engaging in a complex thermoreaction. Adding to the wave of excitement, a new update surfaced across social media platforms through the account Global. In this update, Kaku highlighted an extraordinary possibility that close monitoring on October 30th could reveal whether the object picks up additional energy during its solar flyby. If 3I/Atlas were to accelerate in a manner inconsistent with natural gravitational assist mechanics, it might suggest the presence of an unknown propulsion system, or, at the very least, behavior that does not fit within our existing models of cometary dynamics. Kaku stated that such a phenomenon, though highly speculative, would be a potential clue pointing toward artificial origin or intelligent design. While scientists remain cautious, refusing to jump to conclusions without evidence, the idea has stirred the imagination of millions who are captivated by the possibility of extraterrestrial engineering. Even without such extraordinary interpretations, 3I/Atlas remains an invaluable scientific treasure. The study of interstellar objects is still in its infancy, with only a few known examples recorded in modern history. The first, 1I/Oumuamua, sparked global controversy with its unusual shape and acceleration patterns. The second, 2I/Borisov, provided astronomers with a cleaner look at a naturally occurring interstellar comet. Now 3I/Atlas stands as the third confirmed visitor from beyond our solar neighborhood, and potentially the most revealing yet. Because its activity levels far exceed those of Borisov, and its structure appears more complex than Oumuamua, researchers hope it will serve as a sampling probe from distant star systems, carrying chemical signatures and physical properties that could teach us about the diversity of planetary formation across the galaxy. As the object continues its approach, telescopes from NASA, the European Space Agency, and observatories in Japan and Chile have locked onto it, collecting a continuous stream of data. Spectroscopic analysis of the comet's tail reveals traces of unfamiliar compounds mixed with more common materials, such as carbon dioxide, water ice, and organic molecules. Some of these chemicals may have formed under conditions vastly different from those present in our own solar system. If confirmed, this could expand our understanding of the environment in which the comet originated. The distribution of dust particles within the jet also provides clues about its structure, suggesting that 3I/Atlas may have undergone violent collisions or internal fragmentation long before entering the solar system. In the coming days, as it swings perilously close to the Sun, astronomers expect the comet to undergo dramatic transformations. The intense heat will melt and vaporize more of its surface, potentially triggering multiple outbursts as pressure builds within the nucleus. These eruptions could cause temporary changes in direction or rotation, offering further insight into the internal composition and mechanical integrity of the object. Some predict that the comet might fracture into smaller pieces, a fate that has befallen several large comets in the past. If such fragmentation occurs, each piece could follow a slightly different trajectory, creating a cascade of data-rich opportunities for scientific study. Despite all the excitement, researchers continue to emphasize caution and scientific rigor. While imaginative ideas about extraterrestrial origins make for thrilling conversation, they insist that extraordinary claims require extraordinary evidence. Still, they acknowledge that the mere possibility of encountering an artificially modified interstellar object, however remote, serves as a reminder of how little we truly understand about the universe beyond our sun's gravitational influence. Whether natural or not, 3I/Atlas is an ambassador from unknown realms, offering humanity a fleeting glimpse into the cosmic wilderness. The public fascination with the comet shows no signs of slowing down. News outlets, social media influencers, and science enthusiasts have flooded platforms with images, diagrams, and speculative theories. The hashtag 3IAtlas has trended globally as people share their excitement and curiosity. Michio Kaku's recent appearance on Newsmax, where he discussed the comet's trajectory and potential scientific implications, sparked millions of views and thousands of comments. Many are captivated by the notion that this visitor could reshape our understanding of space, physics, or even the potential existence of intelligent life. For astronomers, the next several weeks may prove to be among the most scientifically productive periods in recent memory. Every hour of observation brings new details, each jet eruption, brightness fluctuation, and trajectory shift adding to a growing body of knowledge. Even once the comet completes its flyby and disappears into the blackness beyond the sun, the data gathered from this brief encounter will fuel research for decades to come. Scientists hope it will inspire future missions to intercept interstellar objects, allowing humanity to study such phenomena up close rather than from millions of miles away. In the end, the arrival of 3I/Atlas reminds us of the profound interconnectedness of the cosmos. We often look to the skies seeking answers, guidance, or reassurance, and, on rare occasions, the universe responds with a spectacle that reignites our sense of wonder. Whether this interstellar comet is simply a breathtaking natural event or something more mysterious, its presence has already touched the imagination of millions. It has pulled humanity's attention upward, beyond the boundaries of Earth, and encouraged us to confront the vast unknown that stretches beyond the stars. As 3I/Atlas completes its fiery dance around the sun and heads back toward the infinite expanse, it leaves behind not only a trail of dust and vapor, but a renewed appreciation for the mysteries waiting in the deep, uncharted regions of space.